Hello everyone. In this video we are going to use Jamovi to help us out with calculating answers with regard to a binomial distribution. So remember, a binomial distribution is a special type of discrete random variables, and it follows this pattern where we have a probability of success and we're running through a fixed number of trials. Okay, so let's go ahead and look at our scenario. So it says Jane loves to go fishing. She has fished up in the bighorns so much that she knows that for any hole this time of year that she drops her fly in, she has a 63% chance of walking away with a nice trout. Assume only one trout per hole. She needs to catch fish for dinner, and she knows that she can only hit 5 holes before she needs to go cook. Before she goes out, her brother says, "I bet you can't come back with more than 3. Should she take the bet?" Hint, she only takes a bet with her brother if it's at least 50-50. Okay, and then note report all probabilities and decimals for accurate to 3 decimal places. Okay, so should she take this bet? Well, before we go and answer these things, we need to kind of dig down a little bit into what we're actually working with. So let's open up just our editor so that we can write a few things down and just have it for reference. Remember, we're going to go to our gear, show output and code just to kind of help us out just a little bit. And the first thing that I'm going to write out is I'm going to say that pi equals 0.63. And the reason is because that's the probability of success, that it's the true probability of her fishing at any given hole. And we know that the number of holes that she's going to go to is 5. And for binomial, as long as everything is independent, that's like all that we need. We need to know the probability of success and a fixed number of trials. She's going to 5 holes. Now, her brother asks this question, and it's this probability statement. So it's this probability that x is going to be greater than 3. Or we could also say, remember, that equals the probability of x being greater than or equal to 4. 2 different ways we can write that probability statement out. So that's the probability, and her brother says, "I bet you can't come back with more than 3. Now, if we can do these calculations and we find that the probability is at least 50% for her to catch more than 3, then she'll take the bet. But if not, she won't take the bet. Okay, so let's go ahead and run this real quick. We'll probably get an error code because we can't find this function p, and that's fine. Let's go ahead and hit an enter real quick. We'll run this thing again. And so we got 0.63. It can't find this function, and that's okay because all we were doing is so that we have it kind of referenced up there. Oh, and it's getting really angry at me now. Okay, we'll just remove this and we'll rerun it so that we've got that information. Okay, so now that we know kind of how this is set up, it's discrete random variable, right? Because she's either going to catch a fish or she's not going to catch a fish, success or failure, and fixed number of holes. So let's go to distraction, this little add-on right here, and we're going to go down to our binomial distribution. And here it has these 2 parameters that we need. It needs the size, how many holes we're going to, 5, and we need the probability of success, which was 63%. And one thing that Jamovi doesn't give to us like natively is a probability table, but we can actually build it because the probability table, it basically just gives it to us in graphical form here where it is plotting the support and the probability mass function. And then if we want the CDF as well, we can get the CDF from there as well, and I'll show you how to do that. So the first thing that we're going to do, I actually want to build a probability table. You don't need it, but I just want to show you how to do it in case if you wanted to build a probability table. So go ahead and grab Excel, and let's start off with our support. So that should be capital X, and it's 0, 1, 2, 3, 4, 5. Now, remember, with a binomial, the support starts at 0 and then goes to the sample size. The reason why it starts at 0 is because it is possible to have 0 successes. Is it possible for her to go to these 5 holes and catch no fish, catch 1 fish, catch 2 fish, all the way up to 5? And the answer is yes. Even though that it's a low probability of her catching no fish, it is still a possibility. Okay, so then we also need the probability of x equaling a specific member of that support. And if we go over and capture this, we can click on compute the probability, and we have the probability of x equaling x1, this value right here. We start off with 0, and we have, for our first one, 0.007. We can go to the next one, go 1, and we've got 0.059. We can go to 2, hit enter, and we've got 0.201, go to 3, 0.342, 4, 0.291. And if you notice, it's highlighting on the graph where we're at. And let's do one more, 5. And we've got 0.099. Now, to see if we did this right, we can do equals sum, add all of these up, and remember the sum of all the probabilities in the probability mass column should equal 1. Now, if you notice, you're like, hello there, it doesn't equal 1. The reason is because we have a little bit of a rounding error, right? Jamovi, in this case, only shows the decimals out to 3 places. And even if you try to go in and increase the decimal format for the number or the p-value, like it won't increase the decimal size. If you really want to get deeper into that, there you can go use the functionality in R where you can run the code for binomial probabilities. But we're not going to get that deep into the code. You can look that up on your own. But this is close enough for us right now. As long as we are accurate out to 3 decimal places, we are going to be okay. Okay, so that's how we could do the probability mass function. And then if we do like the CDF, right, or the probability that x is less than or equal to x, then that would equal this guy, and the next one is equal to the sum of those 2, then equal to the sum of those 3, equal to the sum of those 4, equal to the sum of the 5, and then equals to the sum of the entire thing. And there we go. We get our entire EMF and our CDF, and now we have a probability table. Okay, so you can see how this could be tedious. Like, what happens if you had like 20, sample size of like 20? It would start to take a long time in order to do this. Other programs will also just produce the table for you, but you really don't need it if you're able to just calculate the probabilities directly from here. Okay, so let's go back to our problem. And so we're looking at this question. So she says, before she goes out, her brother says, I bet you can't come back with more than 3. So let's see, what is the probability of coming back with more than 3? So let's compute this probability, change it to 3, and say greater than or equal to. Now, we have a problem though here, because we said greater than or equal to 3, but her brother is just saying come back with more than 3. So we don't have just a greater than symbol here. So if we want to do greater than or equal to, we need to change this to greater than or equal to 4. And now we're at highlighted of greater than 3. So should she take this bet? Well, the probability of her getting more than 3 is only about, 39%. So we should say no. And the reason is, it's because it's about 39% for her to catch more than 3. Okay, and then we've got a couple other questions. What's the probability that she catches exactly 5 fish? Well, if we go to the 5 here, 5, and we go to the equal sign, we get 0.99. Oops, wrong one, sorry. 0.99. All right, next one. How many fish is Jane expected to catch if she were to do this challenge repeatedly? Okay, so this is the expected value, and if you remember, let's go back to our Excel document. Remember, for an expected value of any discrete random variable, what we can do is we can do this extra column, right? We can take the support multiplied by its specific probability of success, and then we sum it up. Let's just go equals to support multiplied by its probability, drag it the whole way down, and then the expected value is just going to be equal to the sum of this entire column. Okay, so that is a way to do it, but with binomial, there's a shortcut. The expected value is also just the number of observations or the number of trials we're going to run multiplied by the probability of success. And we have those values already. It's just 5 times 0.63. And we get 3.15. So there's a little difference here. Once again, the reason is because we have a little bit of a rounding error. But yeah, n times pi is going to give us our expected value. If we were to run this scenario over and over and over and over again, then the expected number of fish on average is 3.15. Okay, next one. What is the standard deviation of the fish? Okay, so let's go back again to our Excel. Now, there is yet another way that we could do this. There's another column that we could do, but there is a much, much easier way. Like if you want to go see that, you can go reference some of the previous lectures that we've done on how to actually do that by hand. Let's not do that by hand. So instead, what we can do is we can do n times pi complement. That will give you the variance. So let's put that right there. We'll say that the variance equals that. And then to take the standard deviation, we just need to take the square root of the variance. All right, so let's give it a shot. So equals 5 times 0.63 multiplied by, and then I'm just going to do 1 minus 0.63 just to get our complement. Get that out, and we get this 1.16. And so then the standard deviation is just going to equal the square root of this value that we just calculated, and it's 1.079, etc. All right, bring that down, and we get 1.079. Excellent. Okay, next one. Given that her brother won the bet, what is the probability that she caught no more than one fish? Okay, this one's a little bit more involved. We've got to take a couple of steps here in order to track down what the correct answer is. So let's go back to Excel and let's write out this probability statement again. And we can use some of the tools that we've got both in Jamovi and in Excel to get this one knocked out. So let's go ahead and write out this probability statement. So first of all, what is the probability that, and let's just write it out in text. What's the probability that she caught no more than one fish? So we'll just say no more than one fish given brother one. Okay, so that's just kind of in texty terms. Now let's convert those kind of wordy terms into a more probability statement. So we can do probability that for no more than one fish, it's going to be x is less than or equal to 1, given, when her brother wins the bet, that's going to be probability, or it's that x is going to be less than or equal to 3. All right, so that's our conditional probability statement. Now we know that conditional probability statement, remember, let's just write out the generic one again. Probability of A given B is equal to the probability of A and B divided by the probability of B. All right, just so that we remember that again. So what do we need then? We need the probability of the intersection of x less than or equal to 1 intersect with x less than or equal to 3. And then we also need just the probability of x less than or equal to 3. All right, so we need these couple. So the intersection, let's kind of go look at this graph. So less than or equal to 1, intersect less than or equal to 3. So let's just kind of put this up here real quick. We'll do a 3 and we'll do less than or equal to. All right, so this is given that her brother wins, less than or equal to 3. Where does this intersect less than or equal to 1? And these overlap at just less than or equal to 1. Okay, so all we need to do then is calculate out that less than or equal to 1, and we get 0.066. Excellent. Let me grab that. And let's get less than or equal to 3 now. 0.609. And then we just need to take them and divide them by each other. We'll have to see if we get close enough real quick. 0.10837. This one is going to give us 0.108267. Now, the reason why we have a little bit of discrepancies in the calculations here is because we are doing a calculation with rounded values, but we are accurate to our 3 decimal places, which is exactly what we need. If you want to get this in further decimal place like accuracy, if you want to be accurate past 3 decimal places, what you'd have to do is use some more detailed tools with the ArcMander lines. And we can do that, but we are sufficiently happy with what Jamovi has given us. All right, next one. What's the probability that Jane catches between 1 and 4 fish inclusive? Okay, well, Jamovi actually helps us do that too. We can compute this probability. We go from 1 to 4 and say between these two, it's going to highlight us 1 to 4, and we get this probability of 0.894, and we get 0.89 rounded to 3 decimal places, 4. Okay, so that is how you can use Jamovi to help answer questions that are utilizing the binomial distribution. Best of luck to you.